Hey guys, welcome back to another Kata video. This time we're doing the Wa-tor. So I have the sharks moving. You can see them eating all the fish, but the fish aren't moving whatsoever, meaning they're not breeding or anything. So let's get our test running. We're going to describe move fish. And the context function is going to be the get move for fish. And it should return a random, unoccupied, adjacent space. I don't think we have enough to go on yet, so let's go ahead and make just an adjacent space function. And it's just going to return all the adjacent spaces of 1, 1. So it should contain 0, 0, get adjacent, and we're just going to make a vector in this new function that returns 0, 0. I'm going to check that for every adjacent space. I'm speeding this up a little bit just to save you from having to watch meticulously adding in each one. Priming our test, if you will. Alright. So now that we have this, let's refactor it. And we're not going to do this for every 1, 1, 1, 2, 2, and everything, so let's get some list comprehension going. Destructured our x and our y. I'm going to use a capital Y to represent that, but we're going to have a decrease of y, and an increase of y. The same with x. Make sure it's not equal to the original position we put in. And let's just return our x and y. And that gives us everything that we just had. Now the tor part of Wa-tor means it wraps around the board, so let's make sure it wraps around the board if the value is below bounds. Contain 1919 if we put in 0, 0. We get a lot of negative ones come back. We can't have that. Let's make a helper function. We'll call it wrap grid. If it equals the x or the y, -1, then we'll have a decrease of the row size. And let's go ahead and put that in here as a map to make sure it does it to every value. And we're good there. Now we need to do the same thing if it goes above bounds. We're just going to swap these values. This will now be 1919. And you'll now be 0, 0. And so we don't have a nested if statement, let's turn this into a cond. This will be our default. And if it equals the row size, then make it 0. That should be it for adjacent. Now let's get the vacant adjacents. It returns all vacant adjacent spaces. And we already have a proof that 1, 1's working, so let's make that our position. 1, 1 for our adjacent. Since we have a test on it, we can pull that in, get the adjacents of 1, 1. Now our fish list. Let's create a list, and let's say that there is a fish that's in the first of the adjacent spaces already. We want to make sure that that's filtered out whenever we run this new function. So the order doesn't matter of how these get returned. We're randomizing everything, so let's just make sure we're getting a set. It contains all these things with a set. We're going to make sure we get the rest of adjacent spaces. This one's going to be a set also. Let's get vacant adjacent. That's our new function. Vacant adjacent of position. And fish list. And just for readability, we'll put that right below this one. Alright, simple enough. Let's just return the rest of the get adjacent. Now, but what happens if the first and the second of of this new fish list are adjacent to us. The next one has to drop 2, and what we just created does not work anymore. So let's go ahead and find the adjacent is get adjacent position. All occupied, we're just going to map over that whole fish list and get their positions. And we are going to use the set difference to see the difference between the 2 lists if it's not contained in the adjacent. And that gives us our new, all the vacant adjacents. So this one we know we have random. So let's get our stubs out so that we can define random to not be so random in our test. We're going to have randinth, and we're going to stub randinth. And let's invoke that so randinth now just does first. That way we can test it a little bit better. So let's pull out this one. We're going to reuse majority of these, except this time we need a fish to go in. So let's create a fish in that position that we have. And this should equal the first of the fish list. Alright, now let's create our new function. This one's going to come from core, because we're making a def method more than a new function total. And let's define our method. Let's move core. This one works for if the creature is a fish. And this is easy enough. Randinth, get vacant adjacent. Position of fish. And here's the fish list. Let's use some destructuring to make this a little more readable. Now we just have position fish list. There we go. And I'm going to just double check that we are working with everything, if it's going to work with the second of the adjacent also. Don't foresee any issues, but it never hurts to have a little extra testing. We're still working. Now our final condition, we need to check that if the fish is surrounded, that it just returns its original position. So we know all this works. We're going to make a map of all adjacent spaces and create a fish in that space. And that's how we can make sure that we're surrounding our original fish. And it should return its own position. It is not. We are getting nil. So let us define our vacant adjacents. And if that list comes back empty, we're just going to return our original position. And if not, what we had before. And just for some for readability, we're going to add this vacant adjacent here. And let's make sure we're running. And as you can see, all the fish are acting as they should now. Thank you for watching my kata.